Welcome back, everyone. It is time to talk a little bit about nested loops. Now, we've talked about nested ifs, and that is an if inside of an if. So as you can imagine, a nested loop would be a loop inside of a loop. So let's see, just your basic loop. Five I plus plus. And we come over here, and we just do a little bit of printing. Let's go with and we'll add the I to it, and a little inline. Okay, so there's a single loop there. And you'll see it goes fuzzy pickles 0 through 4. All right, so we've done this for the most part. I probably should add a little space there. And I think I may have explained this before, but you'll notice it's for int I equals 0, I less than 5. The I is just kind of a historical, I guess you could say, remnant. Back in the original days of programming, it was one of the few variables that wasn't like reserved for other things, like drive letters and such. So it tends to be what everybody uses for these loops. It does not have to be. Again, I could just call this count if I wanted to, and just rename each of these little things, and it would work just fine. So really, it's up to what you want to do. But in most books, you'll see it's for I. And if you have a nested loop inside of that, it's usually the next letter, J. J less than 5, J plus plus. And of course, I will brace that as well. And I forgot to put my int there, but I'll fix that. Int J. There we go. Now, I'm going to make a little print message up here. Cout. First loop. Or I should just call it outer loop, perhaps. And of course, we'll add the I there. The inline or a slash n. I'm going to change this to J because I'm in the J loop here. And 4. Now, if you want to be a little more specific, again, I'm putting these braces or these comments at the end of the braces just to keep things a little better organized. So if I have, extra braces here, I can find them easier. If I have an extra open brace up here that I didn't realize, like that, some of these would be wrong and it will mess things up. And I can clearly see what's supposed to end what when I do this. So I may put a little bit more information here. This is J, this is I, whatever you want to do to kind of differentiate it. But this is a nested loop. I have a loop inside of a loop. Now, first and foremost, and actually let's go ahead and put a little /t in front of that. /t is tab, 5 spaces, and actually I should put it down here. Now, the first thing I want to say before we run this is, how many times do you think this will run? I've had people give me the correct answer. I've had people say 10 times. Let's see, this runs 5, that runs 5. And if these were separate loops outside of each other, then 10 times would be correct. But since it's inside, this will run 5 times every 1 time this runs. So 5 times 5, that gives me 25 runs. So what this looks like is this. Outer loop 0, it runs 5 times. Outer loop 1, it runs 5 times. 2, 3, and 4. So you see it runs 5 times. If I make a little change up here to, let's say, 2. Well, now it runs 10 times, 0 and 1. But inside, it's going to run 5 times each time. This is particularly useful for 2-dimensional arrays when we get to that. two-dimensional anything, maps and such. That's a lot of time what this would be used for. Think of going through an Excel file or something like that, or a database even. Or text. You have an entire page of text and you want to go through it one letter or one word at a time. This would be the kind of thing you're looking at. Or if I was just printing things on the screen, one would control going across and the other may move me down, and then I would go across again. That's what this type of loop would be used for. And of course we can do this with while loops as well. I can just simply say, well, while this isn't true, do this. Or I could do exactly what we did here. I can just make a couple little variables here. Int count1 equals 0. Int count2 equals 0. And then I can just say while count1 is less than 2, let's say, if I'm doing the same thing. And I can say, well, while count2 is less than 5. I can do the exact same loop. Now, these don't have to be counting loops. They could just as well be just while this condition isn't true, while a Boolean isn't true. This is pretty good for like a menu system or something like that. That's where this would typically end up coming from. Let's say I have a whole menu that I want to see, and I'm going to keep looping that until I choose the right thing. Shut this down when I hit this particular number, but otherwise just keep me on this menu. Or if I want to navigate to another sub menu, maybe I would have nested loops for that, and you can nest this fairly deep. We don't generally go beyond 2 in most cases, but you will see 2 or 3. Particularly, a good example of that would probably be sorting algorithms. We have an array or a list of thousands, millions of numbers, and you need to sort them in a proper order. Well, a basic sorting algorithm would probably have several loops. There are better ones that don't use loops, at least not exactly. They use recursion and things like that, but the very basic ones would use loops pretty similar to this. So that is your basic rundown of how basically nested loops work for the most part. Again, you could do the same thing with a while loop. Now, my while loop, I should point out, is missing the counters. So I probably should do that. Count plus plus, or it's count 1, I should say. Count 2 plus plus. That just, by the way, adds 1 to that value there. So I could say plus equals 1 and get the same result. I'm just going to print a little message. Out just to make sure that works. Meh. There we go. So I do not have, let's see, there's 1, there's 2. Okay, we're good. So let's run that real quick just to see. It should print pretty much the same amount of times. Meh, 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 meh. Okay, so we got 5. Let's see. Oh, I said less than 2. Goes up by 1. And both of these do the same thing, so it doesn't particularly matter there. Oh, I didn't have an outer print, so let's kind of do that to make it look the same. Cout, bleh. Okay. And I will add a little /t, which is 5 spaces in front of that. Okay, so let's see what we got. I'll run it. Blah, it printed. Oh, the second time it didn't print. So let's take a look at why the second time didn't print. It printed that, but this one didn't work. Okay, here's why that didn't work. With a for loop, all of these values are inside. So int j, int I, it's effectively just inside there. As soon as I leave these braces, they don't exist anymore. That's what's known as scope. They're defined in here, in the confines of these braces, and when I leave those braces, effectively it throws all that away. So this int j, for example, it exists, we go 5 times, and then it throws all that away and it doesn't exist anymore. Then it recreates it the next time we run through. The problem here is, with this loop here, I define this outside the loop. So the first time this runs and finishes, count 2 is 5, which is the exact condition for this not to run. So the reason we didn't get anything that second time is because, well, it's 5. If I wanted to fix that, I could always just come here and say count 2, equals 0 again. Because let's see if that works out a little bit better. There we go, like that. So that's a possible problem if we were doing the same exact thing as this. So this and that are essentially the same thing. For loops are a little more useful for going a certain number of times, whereas these would be a little more useful if we were, going until a little something was true. But that is essentially just a quick rundown of nested loops.